Here we are going to look at the mathematical representation of a wave. That means when a wave is produced, wave is nothing but the transportation mechanism of a disturbance. So let us suppose a disturbance is created at O, then it is transported to the other point. So this is how the propagation taking place. This is the propagation, and during this propagation the particles are moving along the propagation path, then it is called as longitudinal. And here at the time of movement they are displaced from their mean position as the prongs are oscillating. So the maximum displacement of a particle from the mean position, that is what we are calling as the amplitude. So let us suppose the maximum displacement is represented by Sm. M stands for maximum. So here this is the maximum displacement, and as I told you, the time taken to complete one wave, that means either one compression or one rarefaction, one compression plus one rarefaction, that is a complete wave. That means one compression is up to here, one rarefaction is up to here. So here to here it is T by 2, which means for the half wave the time taken is T by 2. So half of the half wave, quarter wave, it is T by 4. That means in every quarter wave the particle is going to the maximum amplitude. That means it is coming to here, then coming to here, then coming to here, then coming to here. That means it is taking maximum displacements for 4 times in a complete wave, from here to here, from here to here. So this is the mean position, going to the extreme, coming to mean, again going to extreme, coming to mean, going to extreme, likewise. So during this mean position, then extreme, extreme to mean, again that means maximum displacement it is covering, again to next extreme, then to the mean. That means 4 such maximum points it is looking at, 0 to maximum, maximum to 0, 0 to maximum, maximum to 0. That means in every maximum displacement it is taking T by 4 time, and capital T is called periodic time. That means time taken for one wave or one oscillation. So in every quarter time it is going to the maximum amplitude. But if at all you want to know at any time T, for example here to here it is T by 4, after T by 4 it is going to the maximum amplitude, but at some point T, let us say at some point T, because here I am taking time on the x-axis, displacement on y-axis. Therefore after time T, after starting from 0, that means at some instant, after time small t, where the particle is going to be, how much displacement it has. In order to know that, let us say it is displaced by an amount of S from the mean position, then that S can be a function of its maximum displacement, and 2 physical quantities you need to remember here. One is called as propagation constant and the other one is called angular velocity. Propagation constant can be represented by 2 pi by lambda. That means every wave has got its own propagation constant that depends upon the wavelength. So propagation constant is a function of wavelength that can be written as 2 pi by lambda, and units coming out to be meter power minus 1, because lambda is in meters, it is coming to the numerator meter power minus 1, and omega is nothing but angular velocity, that is nothing but number of radians per second. So in every periodic time it makes 2 pi, so it makes 2 pi radians. That is the reason 2 pi divided by the periodic time, that is called as angular velocity. That means the displacement of a particle at any instant of time can be calculated if you know the time where you want to know the particle position and the wavelength and the time period. If you know the 2 parameters, time period is nothing but time taken to complete one oscillation. If you know the periodic time and the wavelength, you can easily locate the particle after time small t. That is what called as the displacement of a particle during wave motion. So this is what the mathematical representation, by means of which you can easily find at what position the particle is during its propagation. Similarly, whenever the pressures are varying, as I said, whenever you take, and this is the case when wave is propagating in positive x-axis along positive x direction, If it is negative x, then this is going to be a positive sign. That is none of our discussion over here. Here we are to look at what is the wave along positive x direction. If it is negative x direction, that means wave is going in this manner. This has to be replaced by a positive sign over here. Similarly, if the pressure variations are taken into account, so this is the 0 point and maximum pressure it takes over here. When the particles are compact, then it experiences a maximum pressure. So delta P, the change in pressures can be change in pressure multiplied by, you can write a kx minus omega t. So this gives rise to the variation in pressure. So this is how you can represent the displacement of a particle during propagation as well as pressure changes during the propagation. And using this terminology or using these mathematical relations, you can calculate what is the velocity associated with the particle and what is the acceleration of the particle. All the other things you can calculate easily by using this mathematical representation.